Hello friends, this is Isham Mishra from noobDEV and welcome back to a series of tutorial on MIPS assembly language. So today we are going to see how to print floats using MIPS assembly language. So if you have not watched our previous videos, so I recommend you to watch them first. So yes, let's get started. So here is a Visual Studio Code. Let's create a new file, new file, Control S, print floats.asm, save, .data, .text, .data which contains all our variable declaration in random access memory. Let's print the value of acceleration due to gravity. So here is our variable g dot float dot float 9 point. So variable name float for floating type, and here dot text which contains our program execution instructions. Main function, load immediately at register V0 with a value of 2, and load address, load a word from coprocessor 1. Address register F12 with a value G, and this is called, don't worry, I'll explain these lines later. So here we are assigning a value 2 to register V0. Previously it was 4, so 2 here is for floats. So it tells the system to print the floating point numbers, and here what this line means is load word from coprocessor 1. So let me show you, just a second. So here, as you can see, we have loaded a register called F12. So here is coprocessor 1, and see, coprocessor 1 contains F12. So from coprocessor 1 we are loading F12. So here this line which says load from coprocessor 1 F12 and assign it the value of G. Okay, and then load immediately V0 with a value of 10, and syscall, and as earlier, and main. As in previous videos, this is for terminating the program. So yes, let's check our output. qtspem print _1 open, and let's run it. So here is an interesting output. We have an input value of 9.8, and we can see that our output is 9.80000 and 19. So why this happened? So let's check why this happened. So internally, what happens when we input a value here 9.8, which is of base 10. So the computer reads only stores in only binary format. So this is converted into binary format, which is 0, 1, and then before printing it is again converted into a decimal format. So decimal, binary, decimal. Okay, so let's go here and enter our decimal number, which is 9.8, and convert into binary. So here is our binary number. Let's copy it. So once again, this 9.8 is converted into a binary number and stored in random access memory, which is then accessed by our F12 register. Okay, now let's convert this binary which we have copied to decimal. Okay, so I pasted it and convert. So here you can see that our decimal number is not 9.8, but is something little different from it. So this happens due to conversion of binary into decimal and decimal into binary. So yes, we have completed one more video, one more program. So thanks.